Hello, eighth grade. Today we're going to work on some computation involving radical expressions. So the first thing we want to do is just really quickly take a quick review on simplifying radicals. So there are 4 problems here. If you could pause this video and simplify them, and then we'll come back together and check it. All right, so these are the answers I came up with. Hopefully you came up with something similar to that. So take a second and check your work. All right, so let's just review what it means to rationalize a denominator. If you remember, our rule is that you can't keep a radical in the denominator. So in order to get rid of it, we can multiply something in the form of a fraction of 1 that would release that radical. So in this first case, if we multiply by the square root of 11 over the square root of 11, that then gets rid of the radical in the denominator, because the square root of 11 times the square root of 11 is 11. And now we have the square root of 3 times the square root of 11, which is the square root of 33. And that is in its simplest form. There's nothing more you can do with that. All right, the square root of 5 divided by the square root of 8. Let's just multiply by a form of 1. Ooh, sorry about that. And now we have 8 in the denominator, and 5 times 8 is 40, the square root of 40 in the numerator. Now, that can be simplified because I know that 4 is a factor of 40, and 4 is a perfect square. So we could factor out the square root of 4, which is 2, and we're left with the square root of 10. Okay. Oh, and then we could simplify the whole numbers. So we would write this as a square root of 10 divided by 4. Okay. All right. On the next one, we multiplied, rationalizing the denominator, we multiply by the square root of 2x over the square root of 2x. And that gives us 2x in the denominator, and the numerator now would be the square root of 30x. And 30 doesn't have any kind of perfect square factors, so I think we would just leave that as is. Okay. All right, so now what we're going to do today is starting to work with operations with rational expressions. Today we're going to focus on addition and subtraction, and tomorrow we'll work on multiplication and division. So first of all, the concept of like terms also applies to radicals, like it does to fractions and units of measure and algebraic expressions. So here's a problem where we have the square root of 2, and we're going to add 3 more square roots of 2 to that. So square root of 2 becomes the like term. So if we have one of these and then we add 3 more of them, that would give us 4 square roots of 2. The square root of 2 sort of is the thing that we are combining. So now here we have 7 square roots of 3 minus the square root of 12. Well, those are not like terms. So now we have to think about what could we do to create like terms. Well, one thing you might notice is that the square root of 12 is not in its simplest form, because 12 has a perfect square factor of 4. So we could rewrite the square root of 12 as, if we think about 12 is a result of 4 times 3, and 4 is a perfect square, so then we could factor out the square root of 4, which is 2, and we're left with the square root of 3. Now 7 times the square root of 3 minus 2 times the square root of 3 gives us those like terms, and now we would just need to subtract 7 minus 2, and that would give us 5, and square root of 3 then is the thing that we're combining. Okay? All right. 3 square roots of 20 plus 2 square roots of 5. Not like terms yet. So let's see, is there anything that we could do to switch one of the radicals? And we can, because 20 is, the square root of 20 is not in its simplest form yet. So let's think about the square root of 20 could be written as the square root of 4 times the square root of 5. I don't know if that's blocking you guys or not, but let's do that. And 4 is a perfect square, so we could take the square root of 4, which is 2, and we're left with the square root of 5. So we can replace the square root of 20 with 2 times the square root of 5. Now, this 3 here is a factor that needs to be considered. So really, we have the square root, 2 square roots of 5 3 times. So that gives us 6 square roots of 5 plus 2 more square roots of 5, which is a total of 8 square roots of 5. Okay. So 3 times the square root of 3 minus 2 times the square root of 27, not like terms yet, but hopefully you know that 27 can be factored into 9 times 3. 9 is a perfect square. So we could take this part of the expression and simplify it to thinking about breaking out 27 into 9 and 3, going ahead and taking the square root of 9, which is 3, we're left with the square root of 3. So we can replace that square root of 27 with 3 times the square root of 3. But we have to do that 2 times because we have 2 of them. So 2 times 3 times the square root of 3 would give us 6 times the square root of 3. And we already had 3 times the square root of 3. And so we're subtracting these, which would give us negative 3 times the square root of 3. Okay. All right, so your assignment today is to work on page 603 in your book, 1 through 15. I will also post the key so you can check your work. And good luck. I'll see you tomorrow. Bye.